So good morning everyone. In today's session we'll discuss about what is meant by Bitcoin relay networks. So we've already discussed about Bitcoin P2P networks. So this Bitcoin P2P network is actually, what was the basic objective? There were different types of nodes. So it could be a plain mining node, or it could be an SPV node, or it could be a full node, or it could be just a routing node. That's it. So this Bitcoin P2P network, it serves the general needs of a broad variety of node types. The most important thing is, like for example, if one particular miner has identified or validated a transaction, he has to relay it very fast and tell to others that I found it, that I solved the puzzle. Only then he'll be getting that portion of cryptocurrency. So the Bitcoin miner should minimize the time between the propagation means sending of the winning block and the beginning of the next round of competition. So if something gets delayed, then he is not going to get the prize. So the objective is, the network latency is directly related to profit. If the network is very slow, he is not going to get any profit. If the network is very fast, he is going to get some profit. Okay, so what is this Bitcoin relay network? So it's a network which will help to minimize the delay in the transmission of blocks between miners. So I am sending at 10 o'clock. I expect that the block, all the nodes should have received the validated block by 10:02. If it is taking 10:20, by the time another miner has validated and he is sending, so who's going to get the whole profit of Bitcoin reward? It will be the second miner. Okay, so here this is the objective. So actually the Bitcoin relay network initially started in 2015. Why? So that the blocks are sent very fast between miners with very less delay. The network had lot of nodes which was hosted on AWS, Amazon Web Services infrastructure around the world, and it was helping to connect majority of miners and mining pools. And later came another relay network. It was called as Fibre or Fiber, Fast Internet Bitcoin Relay Engine. So these relay networks, you'll see the difference. They are not the replacement of Bitcoin P2P, but rather this network will operate or give additional connectivity between the nodes which are having some special requirements. That's all. Now next we learn about what are the various steps. Say assume that there are already 200 nodes and 201th node, it comes joins. So new node is actually joining. Actually it should discover all the other remaining Bitcoin nodes on the network. Only then it can participate, right? So if I want to start that process, I should get at least the address of one node. So the new node should discover at least one existing node on the network and connect to it. And later it will start getting connection of other networks through this node, this friend node. So for that, any existing Bitcoin nodes can be selected randomly. So if you want to connect to one peer node, what should happen? The node should establish a TCP connection. What's the port number used? It is 8333. Okay. So once the connection is established, then the nodes will start sending a handshake. I think we should have learned all this in networks. How does it start? It will in the version message. So the version message will have all this information. N version, N local services, what services it is able to give, the time at when you are sending the request, and then your address, okay, IP address of the local node, and then the IP address of the remote node, and then subversion and the best height, the block height, right? So this will be sent. So actually when the new node joins, now you have a question. How does it find one peer node? So there are two methods. The first method is to send a query, okay, query DNS using a number of DNS seeds. So already these will be the list of IP addresses that are provided when you install. So these DNS seeds, they provide a list of static IP addresses of stable Bitcoin's listening nodes. Okay, so we saw the various varieties, right? Then from that node you will be able to get the list of few other nodes. So this is how it happens. See, there's a node A, it sends a version, gets an acknowledgement. And after this node B puts a question. Okay, what's your version? Gets an acknowledgement. So initial handshake has happened. Now, once the connections are established, the new node will send one address message containing its own IP address. See, I am so and so. This is my IP address. So it will send to the neighbors. That neighbor will start forwarding that to its own neighbors. So what happens at one point of time, the new node gets connected to all the other neighboring nodes. See, node A sends one address, okay, and it uses another function called get address function. So the newly connected node can send get address to the neighbors, asking them, see, give me the list of IP address of other nodes, that what all you know, you please tell me. So he says, I want to get some address of some nodes. This node B, once it receives, okay, from its table, it is sending 3 addresses and says like, see, these are these people with this IP. Now, what is the best thing? Node A has learned 1, that is node B, and then 2, 3, 4. So now it is having IP address of 4 machines. So it will start doing the process to the other 3 machines, the new found ones, and this is how it gets populated. So if you want to get the peer information, okay, so this is one command you can see here, right? Get peer information. So you can get the address, the services, byte sent, byte received, connection time, ping time, the version, and then the subversion, and then last sent, last received, and then inbound, and then starting height, sync node. So this is what has been written. So here you can see like there are 2 addresses, 85.2.13, 199.39, 58.23, 244.20. See, there are 2. So this is how it starts building itself a very good network among the peers. See, we already learnt like what is meant by full nodes. No? It maintains a whole blockchain, a full blockchain, and all the transactions it will have. Earlier years, might be 10 years, 15 years back, in Bitcoin, all the nodes were only full nodes. Okay. And very recently, we've got these new nodes added, which will either service network or it will service a miner. Fine. And the next thing that we need to learn is like something called as how an exchange of inventory happens. Because I need to get a complete details about all the nodes who are connected. The first thing a full node will do once it connects to its peers is try to construct a complete blockchain. See, I am logging myself as a full node. I want a complete blockchain. So starting from that hash 0, the genesis block, right? The whole block is needed. So starting with that hash block, the new node will have to download hundreds of thousands of blocks, and then only it will get a thought, yes, I have the complete database, right? So how is it done? So the process of syncing, it starts with what message? With a version message. Because in that version message, we saw one parameter, no, best height, which means the blockchain that I am holding and what is the height, the longest chain we already learned in unit 1, right? So the node will see the version message from all the peers and it will come to know how much blocks they have. Once it sees like if any peers has got more number of blocks, right, then I think that will be fine. So the peer nodes will exchange get blocks message, which will contain the hash of the top block in that local chain. And among the peers, one of the peer will be able to identify the received hash as belonging to a block that is not at the top. So somehow it will be able to identify which has got the highest or the lengthiest block in it. So what did we learn? We learned like there's something called as a Bitcoin relay network, and there are messages sent from nodes, from node A to node B, from node B to node A, just to learn about the neighbors, and then some method to find out that I want to have the complete list of the whole blocks. Now we learn something called as a command called as get blocks. If a node has been offline for a few minutes and if it is missing few blocks, or that CPU or that rig was switched off for a month, then sure it is going to miss thousands of blocks. So what will it do? It will start sending get blocks message. See, node B is sending get blocks, right? And then it gets an INV response or an inventory response and starts downloading the missing block. So say if node A is sending get blocks message and this is replying inventory, yes I have, then give me the data, and says yes, take all these blocks. So this is how node synchronization happens, and even if the machine was switched off for some time, you can get a missing block. Second one is SPV nodes, simple or simplified payment verification nodes. So many Bitcoin clients are designed to run on space and power constrained device like smartphones, tablets and embedded system. For this type of node, an SPV method is used. Why? To allow them to operate without storing the full blockchain. That's all. We call it as lightweight clients. So this SPV nodes will download only the block headers. They don't download the transaction in the complete block. So ultimately what happens, whatever is stored in that node is 1000 times smaller than the full blockchain. One limitation is this SPV node, they can't get the full picture of all the transactions because they don't know completely. Whatever is given, it will just try to store. Next is a few more parameters about this SPV. These are verifying transactions by reference to the depth in the blockchain instead of the height. So earlier we saw like it looks for that value of height, but here SPV node looks into that depth. So the SPV node will verify the chain of all blocks and link that chain to the transaction of interest. Moving into some more points about SPV. An SPV node cannot be persuaded that a transaction exists in a block when the transaction does not in fact exist. அங்கே இல்லைன்னா அங்கே இருக்குன்னு சொல்லவே முடியாது. So how can you get it known, like whether this transaction is in that block or not? So this SPV node will establish the existence of a transaction block by requesting the Merkle tree, Merkle path. Hope you remember all this, we learned in unit 1. A Merkle path proof, and then it will validate the POW in the chain. So practically speaking, in case if the network has got well connected SPV nodes, it is more than enough for an application to reside in the blockchain. So you can just look at this command, get headers, yes. Put a request of get headers, you will get back the reply as headers. So that's all about Bitcoin relay network, how a network is established, how it tries to learn about the different nodes, and how do these nodes actually operate. So that's all about Bitcoin peer-to-peer network and Bitcoin relay network. Thank you.